Okay, let's get started. So welcome everyone. This is our next seminar in the seminar series for the Stanford Center for Precision Mental Health and Wellness. And the seminar series is Cutting Edge Advances Towards Personalized Mental Health. And we're delighted to have a wonderful speaker here today, Dr. Fried, and I will hand over to Dr. Leonardo Tozzi, who will do the introductions and host today's seminar.
Thank you very much, and welcome everyone, and thank you very much for joining us, Dr. Fried. I will introduce briefly Dr. Fried. So Dr. Fried is the Associate Professor of Clinical Psychology at Leiden University. He did his PhD in Clinical Psychology at the Free University Berlin. And after that, he worked in several methodology departments at KU Leuven and the University of Amsterdam, focusing on psychometric methods, on formalizing theories of mental disorders, and on modeling dynamical systems. Dr. Fried's research focuses on studying and modeling mental health and illness as emergent properties that arise from complex, dynamical, biopsychosocial systems, rather than as clear-cut categories with simple causes. Within this framework, he is now leading a project aimed at building a personalized early warning system for depression, of which we will hear more today. So we're very excited for your presentation, Dr. Fried, and thank you so much for joining us, and you have the floor. Thank you.
Thanks for the kind invite. I had a pretty exhausting sporting event in the late afternoon, so I hope my voice and my lung capacity will carry over. So if I get too quiet, please let me know. Yes, thanks for the invite. I'm super humbled to be here and a little envious that you guys get to see more talks on personalized mental health as part of the series. This is the team I'm working with at the moment, and many more people actually. And yeah, I want to start with a little story. I guess many of you might know Kenneth Kendler in Richmond, Virginia at VCU. He's always been a person I've looked up to. I think he's one of the most impressive living scholars. I don't think he has a Google Scholar. It would probably just break. So I got to visit Ken for 3 months in Richmond in 2019, and I was incredibly nervous. And Ken has a couple of sort of old, expensive vintage bicycles. I know nothing about bicycles. I should. I live in the Netherlands now, but so here you see a picture on the left of the bicycle he gave me, and he said, "No, the only thing, Eiko, I expect of you is that you take good care of this bicycle." And the bicycle is so fancy that people stopped on the road with their cars next to me and asked me if they can buy it. So, and so it took 2 weeks and I broke the bicycle. Luckily, for me, a bicycle is a simple system. There's multiple elements or components, as we can call them, and their relations among these components, and the sum of the parts of the bicycle add up to the whole. And that means I can use reductionism. I can look at every single part, I can fix it, and once I have done this successfully, the bike works again. Miracle. I don't think that's how mental disorders work, right? I think the bicycle is a bad metaphor. A better metaphor or analogy are lakes. That's another thing really important in the Netherlands. We have many lakes here. I didn't know that until I moved here, but it's a big issue. And in ecology, they've been working for 50 years trying to figure out why some of these beautiful blue lakes turn into these green, turbid, ugly, smelly lakes. And if you can predict when this happens exactly. And they couldn't for the longest time until Martin Scheffer and other researchers in ecology came along and stopped trying to understand just the elements or components of the lakes, oxygen content, number of fish, pollution coming in from the external system or external field, sunlight exposure, and so forth. But until they started understanding the lake as an ecosystem of components and relationships. And then some miracles happened, including they could forecast when lakes transition, but they could also find paradoxical interventions. So in many cases, if you remove the cause that made a lake turn turbid, it will not turn back due to hysteresis effects. The lake will stay gross, and you need to do paradoxical interventions that you wouldn't really come up with based on human intuition, such as you need to fish the the lake empty, for example, to disrupt the system sufficiently to cause a phase transition back into the blue state. So this is sort of my two analogies for mental health, and I think the lake analogy is a much, much better analogy. And I think our field has been stuck in the left analogy for, too long. I wrote this up in a new paper that's accepted in Current Directions. If anybody is curious, can check that out. It's a very short primer paper. Happy to send the link around if anybody is interested. So I don't need to go through this in detail. My work currently is on mood disorders, and they're common, debilitating, chronic. Young people are disproportionately affected, and only about half of the patients we see improve under initial treatment, and of those, half, 50% relapse into another depression. Experts especially in epidemiology, agree that interventions work okay-ish, but prevention is really the holy grail. But the problem for prevention is we don't know whom to intervene on and when, in particular to prevent. And so, I've talked about reductionism a little bit, which is important here. And reductionism becomes more problematic once systems we try to study, such as lakes or mental disorders, become increasingly complex systems, like the weather, the stock market, the internet, all of the examples. There's a beautiful paper by Barabashi, 2013, I believe, the network takeover, that has a number of those. And I think we ought to understand mental disorders as complex systems, which is really pretty mainstream position, I think, today. That's nothing, radical. And there's been a shift in the last decade towards this. And of course, many scholars worked on this earlier. And I think mental disorders arise within a person over time, which is the main reason I'm here today, I think, personalized models or targets. And they're best understood as phenomena resulting from interactions of biopsychosocial elements organized in hierarchies of interdependent levels. It sounds awfully fancy and complicated, although I'm sure most of you have heard these conceptualizations before. And the beauty is that if we understand and conceptualize mental disorders as systems, they can be interrogated from a systems perspective. And that means we can just take all the tools and theories and methods that network science and system sciences have developed over 30, 40, 50 years. The Ising model is from 1921, I believe, one of the most common network models used today in statistical physics, and apply them to mental health research. And if we take the systems perspective, all of a sudden we have all these levers and opportunities. Most of you will, or I guess all of you will know, flocking behavior in birds or fish, where emergent properties arise that we cannot understand at the level of an individual bird. You can study the brains and genes of birds all you want, you will never understand or observe flocking behavior, right? It's the part-whole relationship that's the really interesting here. So as I said before, I can fully understand the macro behavior of the bicycle from studying the micro level. All I need is the components and relations. But in emergent properties, this isn't possible. So I gave you the example of birds. Hydrogen and oxygen is another example. You will never observe fluidity in hydrogen or oxygen atoms. It requires the whole piece to cause things to be fluid. You can never understand the behavior, so the population behavior over time of a predator population if you don't also model the prey population at the same time. They're interdependent. And the coolest thing, or one of the coolest things, is that emergent properties can have independent causal status back on the elements, which I find fascinating. So there's this beautiful book by Sandra Mitchell, who I think has a background in both philosophy and, I keep forgetting the word as a non-native speaker. She's an expert on social, like bees and wasps and so forth. And she has an example, she lists that bees collect honey, and you can understand the honeybee, the beehive, as an emergent property of this collection behavior. It fills up. And once the beehive is full, it causes the individual bees to change their behavior and stop collecting honey and, doing other things, which is just, if you draw this out as a causal diagram, it's just remarkable. Another amazing opportunity we have in a systems perspective is the idea of attractor states, bistability. I'm not sure about your background, unfortunately, but I assume that most of you have heard about these things. You have stability landscapes, you have attractor states in which systems can settle or rest. And the simplest system would be a bistable system. So if I take hope you can see my little video here. If I take a playing card, like a poker card, between my two fingers and I push it, it will go to the left side or the right side. Let's assume it goes to the left side. And then I can push against the poker card and it'll at some point flip to the other side. And that's a bistable system. The poker card cannot be in any other state. Very simple, symmetric bistable system. And I understand sort of mental health states as resulting as emergent properties resulting from a complex dynamical mood system. Biopsychosocial, I sort of gave you an example here. This is, of course, not complete. It's from a grant proposal. And the importance here then is studying the components and the relations among components. And the thing I'm most excited about are early warning signals. I have a slide on that. So this is a stability landscape. This is used in ecology a lot, statistical physics a lot. And on the left side here, you see a bistable system, pretty much my playing card, actually, my playing card example. And in this system, there's a very high mountain between the two states. And that means I press with my fingers very much the card. And so it requires an awful lot of pressure to flip the card into the alternative stable state. Or here, this is a healthy person and life events, stressors, bad stuff happening will move the person to the left and right, but the person ball follows gravity. And so you would need immense pressure to push this person over the mountain into the alternative stable state. But on the right side, you see a less resilient person, maybe because of the current stress, their resilience landscape is less stable, maybe their genetic or neuroimaging effects that play a role here. And now the coolest thing is that there might be ways to assess in which state a person's stability landscape is currently. So this is an example from a paper by Mirike Wichers and colleagues who have worked on this, Van der Leempoort et al., as well Martin Scheffer. So this is done a lot in ecology. And basically, imagine you push both people on the left and right a little bit, a push to the left. You sleep badly because you're worried about an exam, and then somebody gives you decaf accidentally in the morning instead of, coffee. Like that's, for me, that would be like a small to moderate push. I'm going to be grumpy and I don't know where my grumpiness comes from, but it's not going to be a life-changing event for me. The person on the left side, me, for example, would return after a push very quickly to their stable state in which the ball doesn't move. But the person on the left side would roll quite a bit longer in this healthy state. And you could measure this by tracking the ball over time. And that is what my project tries to do. We try to follow people in their daily lives over time. And then you can measure, it's called engineering resilience. How quickly do people return to baseline after minor perturbations? That's the broad idea here. So I got an ERC starting grant here in Europe. That's 1.5 million for 5 years. I don't know how this translates into the R system in the US. And the idea is to build an early warning signal for depression that works a bit like when I talk to journalists, I always say it's like a weather alert. So, you get a prediction that, in 7 days or something, there's going to be a storm. We're never 100% certain, obviously, also with storms, at least in the Netherlands, the weather prediction isn't super accurate. For major events, it might be, but, for like normal storms, it isn't. And then you can really only run away or seek shelter. There's not much more you can do with storms. You can't really prevent them. And for depression, the hope is that we can actually prevent these storms before they occur. And I'm going to talk a little bit how to do that now. Hope that, I wanted to give a bit of an introduction to the complex systems idea before I talk about the project. I think it makes a little bit more sense. So we follow 2,000 students in the Netherlands over 2 years, and they never come to the lab. They don't do neuroimaging, they don't do genetics. It's meant to be a sort of the most feasible way to do the study to maximize sort of recruitment and get as many people as possible into the study. It's based on 3 pillars. I introduced sort of the complex systems idea already. We try to use modern measurement techniques, so smartphones and smartwatches. And yeah, I'm not going to talk about the modeling today too much, but we're going to use both black box machine learning and sort of theory-based approaches. Okay, I can, maybe exclusion criteria. So inclusion criteria are you need to be 18 plus for privacy reasons. You need to study in the Netherlands, but you can be an international student. So most of our folks are between 18 and 24, 25. And we exclude current severe issues, mostly either because they don't fit the study protocol. So if you're currently depressed, we're not going to be able to forecast into depression. So that's excluded. Suicidal ideation, only severe one is excluded because of my ethics board. And then we exclude we exclude very few other conditions where ethics was worried that people cannot give free consent for the study. And finally, we decided to exclude people if they say they might relapse into an eating disorder from a calorie track, from seeing their daily calorie run, because the smartwatches we use do that. And we wanted to be careful here. The study has 3 stages. At baseline, we give people a long questionnaire online. This is based on a Delphi study we did. So, there's a million risk factors for depression in the literature, and we did all we could in 90 minutes, basically. Then stage 2 is 3 months of daily smartphone and smartwatch assessments. I'm going to talk about this in a little bit more detail in a second. And then we follow people every 3 months with a short online survey for 2 years. And that's sort of our main outcome. Do people get sick? And then we hope we can predict when they get sick with much higher accuracy than we've done that in the literature so far. Here are some of that's way too much text on one slide. I apologize, but I wanted to show you that we do a lot of things in the baseline. So
why don't you measure personality?
Sorry?
Was that a question? I heard something too, but I would say if people
happy
have
to answer questions, we can also do it later.
Yes, you can also type them in the chat, and we can answer them in the Q&A at the end. Thank you. Sorry.
Okay, no problem. So yeah, we try to do evidence-based as much as we can here. Some things I'm really happy. So one thing I'm proud of is that we really get into gender identity and experience of immigration and bullying and other issues of where more diverse students feel spoken to. And we've actually had quite a few people reaching out to us about our questionnaire and sort of praising our more diverse questionnaire, where we don't ask about your parents, but we ask about, parents or people you grew up with, and these things that really made a difference for folks who make these experiences. We have some COVID questions in there. And then we talk a lot about not just life events, but how they affected people, because a divorce can be stressful or a marriage can be stressful. But, some of these things are better or worse. And so we always have a second question that sort of quantifies how you dealt with it, how you cope with it, how it was for you in the past. So there's plenty of stuff in here. And we're going to share this measurement battery soon as part of a protocol paper. Stage 2, 4 times a day, we bother our poor participants with about 30 items, but practice shows you can do those in about 3 minutes. So that's quite feasible. I've done quite a few studies on this, and students are quite good with it. We have a few extra questions in the morning survey about sleep and outlook of the day. It's another thing I'm quite happy with, that we actually ask about people's perceived prediction of the future, which is quite relevant in the study. And I want to find out if that helps us predict onset of mental health problems. And we have a few evening questions, 15 or so, that really tackle the day more globally. Many of you might have worked with these EMA protocols before, and sort of for every item, you need to figure out what the right time frame is. And especially for the mood items and the context items, I'm going to show you a few in a second. Sort of 4 times a day is probably a pretty good protocol that participants can handle, but they're like, I don't know, like sleep problems. I don't need to ask them 4 times a day. And then there's some questions we ask once a week only that are really the more global. So I do the PHQ 15. So we disaggregate insomnia and hypersomnia, psychomotor retardation, agitation, and so forth. And we do a couple of outcomes every Sunday about the last week. Here are some of the things we do in the EMA protocol. So typically you'd see affect and symptoms, but we really do context as well. I want to know current activity and enjoyment. Who are you with right now? What's your current location? Most of these are quantitative, but we also have some qualitative text fields that will be a nightmare to analyze, but also a fun challenge for us. But for all qualitative text fields, such as in the evening, we ask what was your worst experience and what was your best experience, we always have a quantitative rating afterwards. So we ask worst experience, and then we ask how bad was it, 1 to 7, and then we ask in which domain of life was it, political, love life, employment, or university. So we have some quantifiers that will make our job a little easier. And then we also ask about perceived burden of the study and why people missed measurements and so forth every Sunday. So people wear a watch. That's the Garmin Vivo Smart 4. Yeah, mostly activity tracking, sleep. It has a stress. It does stress from heart rate, but I'm a little skeptical about how well that works. Happy to answer questions, but it's just your standard smartphone. I can skip this. Well, maybe I should say, so we, the smartwatch data we collect through Garmin, of course, and then we use a Berlin company called FitRocker that get us the data from Garmin. In Europe, GDPR is a pretty big problem, so it was cheaper for me. Instead of writing my own API, it was cheaper to get a company help us getting the data in a secure and safe way. And then I use Ethica as a EMA tool. We've made okay experience. They're not, it's not the best tool, but it's the best one I know. So I'm curious but I've tried 7 or 8 of these apps, and I didn't want to make yet another one in-house that nobody will use later, and you just, abandon it after a couple of years. So we use Ethica. It's fine. Like for the price, it's fine. So that's the study and the protocol. Happy to answer questions about it. And I have a couple more things I wanted to mention here in the next 7-8 minutes. So there's time for questions left. Mostly things that were really fun to make or gave me a big headache. So a lot of fun was our YouTube video. It's like a 4-minute recruitment video that sort of describes the study, sort of with 2D animations of the weather alert and the people getting depression and so forth. And anybody's interested, you can check that out on YouTube. Then I'm on Twitter, but I'd never done Instagram. So it was really fun to recruit people through Instagram and you sort of use social media. I have a lot of young people in the team that are very good with these sort of things, which is nice. Dutch students are also super. I don't know how that's in the US, but Dutch students, Instagram is really the main social platform for them at the moment. They always make fun of me for being on Twitter. Apparently that's an old person's thing these days. But then, oh yeah, I wanted to show you this. I need to stop sharing my screen for a second for this. And share this here. Can you see my browser? Okay, thanks. So every person in our study gets who wants to, after 3 months, gets a personalized data report, and that's a HTML file they get. This is sort of a little bit of a fake report, but I just wanted to show you how this. I mean, this is based on some real data, but we scrambled it a little so the person is identifiable. So in the data report, people get an overview of how to read the report, a couple tips and so forth. Importantly, it's not meant as clinical feedback, obviously. I'm not allowed to do that, and I don't want to do that for the study. It's more like citizen science, you get your access to your data, and because you can't do anything with an 8.5 gigabyte JSON file, here's some data visualization. So first we show them blue means they have completed surveys, gray means they missed some surveys. On average, our completion rate is like 72%, which is quite good for 3 months, 4 times a day. Then they get descriptives of each of some of the items. So we summarized positive mood. We used multiple items here. 1 is bad, 7 is good or high. So this person, for example, has more negative mood than positive mood, which is very rare, actually, which is why I took this example here. And the person was very tired on average, 6 out of 10. That's very, very unusual. So perhaps points to a medical condition. We ask them about current activity. So this person mostly had passive leisure, like YouTube, for example. The person was mostly at home. This was still during COVID lockdown, but also at family's place or outdoors in nature. Offline activity, mostly family or no one. And then online activity, lots of written chatting or nothing at all. This is quite a lot, actually. So 4 times a day for 3 months, and every third prompt, we ask them, they said they were chatting online. We have events here. I'm not going to go through this in detail. And we plot mood over time. So you see yellow fatigue here. This person is very fatigued, but you also can see that it varies a little. And you see that when fatigue goes down here, the positive mood goes up and peaks here. So these are just basic descriptors, but people really like them. We also asked them about utility to improve the report and so forth. Yeah, you guys know Spotify, they do this like wrapped at the end of the year. And we did the same. We like, what's your most positive week? What was your most negative week, or at least positive week, as we called it? And in the end, we also estimate a couple of network models for them that people actually found super exciting. And we struggled a little bit how to explain it, but it worked out quite well. Okay, I'm gonna go this wrong window.
This is Lumen, the first device for hacking your metabolism.
Sorry, guys, I'll be there in a second. There you go. I can skip this. So we just started with the descriptives, of the Garmin data. I'm a little skeptical about the data, honestly, as are most of my colleagues working with other watches, such as Apple or Fitbit. As you might know, it's really hard to get the raw data. They use a lot of proprietary patented pre-processing that they don't tell you what they do. They might update the firmware at any moment, and you know the data looks different. So it's quite tricky. But I just couldn't afford, €1,500 medical devices per person, and also people would not wear them because they look terrible. And my participants are 18 years old, and I want them to wear them when they go to the pool or when they have sex or when they are in the shower. And so we needed this. We chose for some slim devices, but there's some signal in the data. Sleep, yeah, I'll skip this. Yeah, if you ever do this, keep in mind you need to clean the watches. That was one of the things that was not the most positive experience. So we shipped them out to participants and get them back. But it was fun. And then I really wanted to stress how amazing some of the qualitative data is we get. So people talk about breaking up with their partner or hearing a terrible news that their friend doesn't have a long time to live. Ukraine war was a big stressor in our data sets. We see mental health problems peak in that week or two in the Netherlands. Obviously, especially people with an Eastern European background are affected. And also like just qualitative answer of why people miss surveys, like feedback was super interesting for us. So for example, many of our participants sort of were classically conditioned to start hating the assessment because of the beep tone that the Ethica app has. And so we actually suggested to the developers to change the beep tone every 2 weeks, like to randomly iterate through 10 different beeps, for example. Challenges to end this with. Yeah, I mean, just the protocol paper. There's so much measurement to write up, and I want to share my measures and materials and the data, because the goal of this is, if this works out, I really want to try to do this again. And so we want to build an infrastructure that can be transferred to predicting PTSD in people going into combat, predicting burnout in teachers for risk, and so forth. And that's why I want to share the whole pipeline. But that's more work than I anticipated. Ethics, of course, privacy is a big challenge with these studies in general, but we're navigating that pretty well. What to do when we predict accurately? How do we implement preventions? Well, it's not technically part of this grant. This is for prediction, but obviously for anything clinically relevant, we need to figure out how we would do prevention after a successful prediction. False positives might be terrible, obviously, right? You need to think that through. And then, the nature of the Garmin data has me worried a little bit at times. And yeah, we're going to write up the protocol paper right now. It should be online in a month or so, maybe 2, with all study details and measures. Big shout out to the team and everybody else working with us. It's a huge team effort, obviously, collecting these sort of data. Thanks to the ERC for funding my work, and for everybody coming here today and listening to my ramblings about prediction and personalized psychiatry. And yeah, I'm happy to share the slides. So just send me an email, or I can send them anywhere. So thank you so much for being here.
Thank you very much, Dr. Fried, and we'll open the floor for questions if anyone has any. I see in the chat that Dr. Knudsen had a question about personality, but I don't know if it was if you wanted to ask that question still, or if it was resolved.
Yeah, so we assess the big five. That's the time we had in the assessment. We do the neuroticism domain with, I think, 10 items. So we do a little bit more in detail, and the other items, the other domains with 2 items each. I checked the BFI psychometrics in quite some detail, and the 2 items correlate like 0.85 with the 10 items. So I decided that we cut there. I hope that's
Someone is asking in the chat, curious whether climate anxiety shows up in your study.
Yeah, very interesting. We haven't been able to analyze the qualitative data in great detail. I have a few master students working on them right now. It's also super tricky data because they're technically probably identifiable. Some people talk about their love life, and they also take economics 204 in, at this university, and it's like, oh, and they're also like non-binary, and then they're the only person in the data with that. So I haven't seen anything about climate anxiety, but we have a huge sort of dump of life experiences there, and worries might be in there. And I'm currently developing a protocol for sharing qualitative data, but while retaining confidentiality, which will be tricky, or pseudonymization.
We have a couple of questions from the audience still. So first, Nilam Ram.
Hi, yes, thanks very much for the talk. I'm a big fan, especially of the theory methods combination stuff that you're doing is great. So I'm curious, in your choice to measure affect, et cetera, on a 1 to 7 scale, and if and how that pervades future downstream into the network modeling world. We've almost gone totally to 0 to 100 sliders. So I'm curious about the trade-offs of these two.
Yeah, it's a fantastic question. There's a few things I have headaches about. This is definitely one of them. I was sort of on the fence at the end after reading all the literature on VAS sliders, 0 100 to 1 through 7. Well, I'm part of a couple of big consortia where people as like also 50-50 what people do and what people like. My concerns with VAS is that your thumb thickness introduces noise to the data, and that a 34 is just not different from a 37. And 1 to 7 is at least they're meaningful things. But I should point out, as a sort of criticism of that perspective, Jonas Hasselbeck put a new preprint online quite recently studying bimodality in VAS 0 to 100 affect items. And he finds that some of these items appear to be bimodal. And of course, you would not pick that up properly on a 1 to 7 scale. So there's experimental work happening in Leuven right now. I really wish people would study this for 10 years. I really think we should do that. So they give people, they randomize them into number of items and check the psychometrics and, 0 to 100 versus 1 to 7 and so forth, experimentally, like RCT-like, to see the counterfactual, basically, how people would have answered had they had a different scale. But yeah, I don't know. The evidence for me seems 50-50.
Yeah, but do you see implications for what it is that we can do modeling wise later? So the network models are currently all based on lag1 autoregressions that are linear. Do we lose specificity in being able to go to more nonlinear forms in those models?
Right. Yeah, I see that concern, but I think I just trust the data more. I think there's more validity in these item responses than I think. In the end, people round the 78 to an 80 or something like this. I think it just introduces unnecessary error. But I see your concern. Obviously, I'd prefer having 0 to 100 data if they were normally distributed, but they never are. So maybe that doesn't help that much anyway. But I don't know. It's a tough nut to crack right now.
Cool. Thank you.
Great question.
We have 2 questions in the chat. So one is from Dr. Zhang. She's asking, could you please talk a bit more about the network level analysis and visualization and explanation you showed in the report you give to the subjects?
Yeah, I'll go through this one by one, if that's okay.
Oh yeah, you can see the chat actually. Yes.
Yeah, I see them. Thanks. I have been teaching on Zoom for 2 years now, so we're all quite used to it at this point. Thank you for the help. Yes, so I use, in this basic version here, we use regularized or non-regularized partial correlation network structures, like one usually, and then you can do it on the contemporaneous level, and meaning if you are high on item 4 at beep 7, how high are you on other items at beep 7, controlling for all other items at beep 7. And we plot for participants the contemporaneous one because it doesn't have arrows, and I didn't want them to misunderstand arrows that we mean temporally, like 1 as causal, a pretty big danger in participants here. And so we just chose the contemporaneous networks that are undirected partial correlation networks based from on a like one autoregressive model, very basic. And we tried to limit it to 5 or 6 variables and tell them, you know, what partial correlations are, which was the biggest trick. But I think they really got it. The relation between A and B after controlling for C and D seemed clean enough for them. I hope that answers the question. These are not the models I want to use in my actual data for prediction, but I think they're a good starting point for data visualization for participants. Going to John's question, if that's okay. Yes, absolutely. So John asks about, sorry, I'm going to use first names if that's okay. I'm so sorry. Living in the Netherlands for so long, I really hope that's okay with everyone. Likewise, please call me Eiko, obviously. I also, first names are much easier to pronounce usually. Yes, so John asked if the reports could be interventions. Yes, that's a really big problem. So in the second cohort, we might try. So I do 4 times 500 people rather than 1 times 2,000 people. And in the second cohort, we might actually randomize people to, do they get a report or do they not get a report, to sort of see if how strong the intervention effect is. Because people posted this on LinkedIn, they were like, hey, this is my report and I learned a lot from the report and now I will stop smoking and stuff like that. So it definitely happened. But for us, so there was a trade-off. We really need to motivate people to stay in the study for 2 years. And we thought the data report really helps with that a lot. And that's also the feedback we got now. And so the danger is intervention. But I hope that when people do the actual study and we do the same, we also provide them information about their data. So this is not prediction, but when we do the actual prevention part, we do the same, and then sort of the bias is the same in both populations, and that should sort of control for itself. Same thing here. We have a pretty self-selected sample, obviously, for this study, but I hope that the same people who self-select into our study are those who are going to be using that warning app later on that we develop. So in a sense, the controls for each other. Next question. I was wondering if you could speak more about your approach to, you guys need to stop me, right, if I go past the time. I'm just going to go through these now. Thanks for the presentation. I was wondering if you could speak more about your approach to the analyses. Yes. Integrating EMA and Garmin data, for example, huge issue. I think about that every day. So there's a couple of really fancy papers by really fancy groups doing that. And what they do is really sad. They dump down their Garmin data or their phenotyping data to the same level as the 4 times a day EMA data. So you'd simply average over the occasions. What's your average heart rate over these 4 hours? And you put that in the model. There are neural networks that can deal with different timeframes. We're exploring that. I'm not an expert on those, but I have a couple of collaborators who work on those. So I'm quite excited to check those out, but I haven't worked with them myself. Maybe somebody here would know these models that I hope we can use. Yeah, so that's the main concern here. 0 to 100 response options are problematic. How to use the numbers, and there's also variability across individuals and how the 0 to 100 scale is used. Yeah, I agree. I think, do you measure friendship between participants? No, that's a really good question. So we often have pools of participants indeed talking to each other, participating in groups. Often, of course, psychology students who hear about the study tell their friends. And we pay 100 euros for participation. People get to try a smartwatch for free. Need to send it back though. Some people do, most people do, some people don't. Another concern I didn't talk about. And they get sort of information about this, they get this personalized report. So yes, we have groups of participants and we cannot ask them for privacy reasons to identify other people. We could, however, ask, are you good friends with somebody else in the study? Maybe that's a nice idea. Thanks for I'll take that question as a nice suggestion actually for the next stage of our work. I think I'm
there was a question by Sarah Haggerty above this one, asking how you decided what to include in the participants' feedback report.
Yeah, really good question. So first of all, we had to exclude a number of things that ethics wanted us to exclude. I mean, we didn't necessarily ask about that, but it's very obvious that I cannot plot suicidal ideation here, right? It's very, very tricky. So it has to be as non-clinical as possible. And so we avoided the really like non-suicidal self-injury and these sort of items. We tried on the positive negative mood, stay on the positive negative mood level. So we avoided those. And then we looked at psychometrics, like what items show variance in the population, but also at each person on average over time, what are interesting items. Context stood out to us. These are always interesting. Where are you? Who are you with? And then of course, mood and symptoms to some degree were interesting. And yeah, I mean, it's hard to do this empirically. We didn't know, we didn't want to make the reports too long. We didn't want to make them too short, right? And so we had a pretty thorough questionnaire. People could opt in after this to give us feedback. About 15% did, and we got some really nice feedback that we can use next time to make these reports better. The goal is here to develop a Shiny app people can use in their browser, where people themselves can then say, I want to have a network model of items 1, 7, 9, and 14. And I now want to plot over time variables 7, 4, and 12, and so forth. So I have some master students working on this right now. It's technically very easily implementable. You just need to do it. Yeah. Sorry, I missed that question. Apologies.
I think we still have one hand up. Is that another question, Nilam, or is okay?
Yeah, sure.
Go easy on me, please.
I'm very excited. I'm so excited to meet you because we never had a chance to meet before. So even though it's in this format, I'm curious, given the way that you framed your talk up about emergence and dynamic systems and stability fields, et cetera, where do you see as you're going forward in the analyses on what the first round of low-hanging fruit is that you would go after, and then sort of what's the second tier of things which you might obtain from the data in regard to the dynamic systems portion?
Right. So the first part is definitely early warning signals. Sorry. So critical slowing down is one of the ones that people talk about a lot in the literature. So I hope, and this is being recorded, so this is terrible to say, but of course, scientifically speaking, I hope that the big problems. I'm pretty transdiagnostic myself. So we do measure anxiety and depression, and we measure severity of impairment, and we measure quality of life. So, I'll take all of these outcomes and combine them in some way if they load on one component. And we hope. So the first couple of papers will be on early warning signals. There's quite a number of them. Some are theory driven, some are data driven. There's this idea of connectivity, for example, that more connected systems are more vulnerable because once you activate something, the rest will get activated and get stuck there. There's thresholds for connectivity that might be bad, but it's mostly just talk, at least in clinical psychology. Very few people have actually worked on this empirically, and the data sets we've had are too small usually to draw any reasonable inference. So that's a very low-hanging fruit I'm really excited about. And then, yeah, I want to go into neural networks maybe next year or in 2 years and understand the black box machine learning things a little better and see if they can outperform my theory-driven. And I know you guys are probably all nodding like, yes, you should do that. So we wanted to do this both from the theory end of the side and also from the data-driven side.
Yeah, so one other piece in here is how does one, or what are your thoughts on dealing with the non-stationary problem that the network itself may be changing its structural form as you move through across these 2 years?
Yeah, so with 380 measurement points and quite a high completion rate for most people, I really hope I can use non-stationary network modeling. Jonas Hasselbeck, Laura Bringman have worked on those, so there are a couple that I like to use. Just never had the power to do those. And we actually don't know how they perform in empirical data. We've only used them in simulated data so far. So quite excited to try those out.
Cool, great, thank you.
Leonardo, I could ask my question if
yes, absolutely.
that works. Fantastic presentation, Eiko. Thank you so much. Can see it's generating a huge amount of interest. My question is in part comment and just inviting you to speculate, because you have such rich data and this idea of personalizing with the networks like 1, 3, 7 that you were talking about, or choosing those. In some of our work where we're looking at prediction of intervention outcomes, it's looking like there are some features that are more like arguably more trait-like and some state-like, some that may be more trait-like, perhaps the personality, temperament factors that with someone's trajectory, and others that are more state-like and change. Do you have thoughts about capturing that, and whether there are some features that are present kind of pre-intervention that would help subtype or personalize the dimensions that you are capturing and could intervene with?
Yeah, that's a big question. So
Yes.
when we designed, so what we do is we do baseline, and then we measure every 3 months. But at the 1 year and 2 year follow-up, we do a bit of a bigger battery, just because I hope participants will do that. So it's 45 minutes and the others are 20 minutes or 15 minutes. And so in the team, we had so many discussions about when do we measure what? Is it a trait? Is it a state? Is it sort of in between? Does it differ? Is it a state for some, a trait for others? Is it a 12-month trait? Like I don't need neuroticism every 3 months. I think my students might disagree. And then, but for life events or gender identity, do we need that every 3 months? Well, it would be insightful, but it's yet another question we need to ask. And so the follow-up in our study, the follow-up surveys every 3 months also not only serve as outcome measurements, but also as continuing predictors, of course, as severe life events come to mind that are very obvious ones. So I don't have a great conceptual answer. I've been working on a paper for a while that's a little technical, but I try to understand symptoms as having a trait component and a state component. It's very obvious that some of us worry more. Some people are born to worry more. Some people are born to sleep a little worse than others. It's just, or maybe they're not born like that, but it's quite stable. That doesn't mean they have depression. It doesn't even mean they have necessarily sleep problems, but it's just a personality thing to some degree. But obviously sleep and worrying also fluctuates over time. And there's some vulnerability models that, that say maybe even your neuroticism goes up after a depressive episode, or there's some work showing neuroticism goes down a notch, 5-10%, after a successful CBT treatment. Don't know how robust these effects are. It's not my literature, but I think it's interesting to think of most of the things we do in my field as having a state and a trait component. It's a very, very lame answer, I guess, because I'm sort of evading, but that's how we think about it right now. And I think the answers to the questions still out there, how to tackle that.
They're great thoughts, and that idea of how it may be something that's a predictor and an outcome at the same time, I think is really important and fascinating.
Thanks.
Okay. There is another question in the chat that just appeared. Great.
What kind of interventions do you think are going to be most effective within the system? Yeah, super hard to tell. So obviously the big promise of this network approach that people have been working on in clinical psychology for 10 years, that has also obviously reached psychiatry. And obviously you guys have been doing networks, brain networks, for example, much longer, gene networks and so forth, has been to develop new treatment targets. So we have a paper with Don Robineau, and the first author is T. Henry, where we try to merge this idea of network psychometrics with control theory from statistical physics and engineering and so forth, and try to get these two approaches together so that you can try out interventions in the system. Because somebody mentioned formal theories before, human intuition just doesn't do it often. Like, these systems are called complex systems for a reason, because they don't behave in ways that you can just easily predict. Now that leaves many problems, such as, can clinical psychologists or psychiatrists really push certain nodes or buttons in the network? There's a philosophy of causality, we call it the fat hand or fat finger, depending on the language problem, where you sort of like, you try to push a node, but you're really just like, clapping on the whole thing, and you hit 3, 4, 5 notes simultaneously. Tell a psychotherapist, please intervene on worrying. Really hard, but not impossible. There are protocols, of course, for sleep treatments, for example, insomnia. So I hope that building formal theories or formal models of some of these systems, of these ecosystems that have been successful for lakes and other ecosystems, and then figuring out via simulations what interventions might do. And then, of course, we need clinicians involved, what interventions are even possible. Some nodes that are unintervenable, perhaps. To move the system to another state would be the goal. And there's great work by Adele Hayes, for example, on so-called network destabilization in clinical psychology, actually. So the idea is that if your system is in a really strong attractor state, you need to destabilize the system before you can move it to the alternative stable state. And we have a new paper in Nature Review Psychology with Don Robino and Jessica Flake, where we actually talk about a new way to measure depression. And that because people, I've sort of wrote my PhD on this, and people always ask me, Eiko, why don't you make your own depression scale? And I say, there are 280 scales out there already. I don't want to do that. But if we were to be able to measure the system, the mood system, the ecosystem of that gives rise to the emergent state mental health problem with depressive character or whatever, we could measure the, I don't know how you say this in English, but the slope of the attractor state. And one measure of treatment response would not be symptoms, it would be the slopeness, like if the stability landscape slope decreases. And you can measure that from measuring the system if you capture it accurately. Now that's a long way to go, but I think this conceptualization has a lot of implications, including for measurement of treatment response and so on.
I think there's just building on that speculation, Eiko, you also, I think in your data would have the opportunity to help tease apart the heterogeneity of depression, because, we've been so limited by one kind of summary average outcome measure, assuming depression equals mood or sadness, where it's so many different features, encompasses so many different features.
Yeah, a couple of years ago, I put a grant in that didn't get funded called D100. So where I wanted to follow 100 depressed people in much the same way I do this in this study now, and sort of figure out empirically how different they really are. And not only do symptoms. I mean, again, that was my PhD, like looking at all these depression scales and calculating symptom profiles for depression. People are indeed super heterogeneous, also in terms of their etiologies, of course, right? Some people are just born and they worry a lot, and and some people have a lot of accidents. They're adversity and stressors play an important role. Attachment. I mean, there's a reason we needed 90 minutes baseline battery to even capture the most common predictors for depression. And so I hope one of my students, Carlotta Rieble and Ricarda Proppert, they're both going for their research questions. There's always the added question, and how well does it generalize across people, no matter what we do? For some people, onset might be categorical, so the black wave of depression falling over me. Others might have a gradual onset. We don't know that very well. For some, certain early warning signals might be there. For other people, maybe other early warning signals might be there. So it's a very, very good question and important point in the study. And we try to do everything at both the idiographic level. We have models for that today. That's amazing. We can do it both ways. We can do it on a nomothetic level between subjects, but we can also look how much individual people deviate from that average, and if the average is meaningful at all, or if people are really just their own ecosystems. I think the truth for depression and anxiety will lie in the middle somewhere. I think there are some general rules we could find, but I think of them as sort of contingent rules that don't generalize to everybody.
Thank you.
So, I know many of you are working on problems. I'm sure many people face the same problem. So we have a lab meeting every Friday where we invite people in this domain on space. Just reach out to me. I'm always happy to host you and exchange ideas and try to tackle these things together.
Thank you so much. Then thank you very much, Eiko. So I don't know if we don't have any more questions. This was a fantastic talk, and I think we got this awesome discussion. And yeah, so thank you so much again for joining us today. And yeah, we'll keep in touch as you said, keep trying to unravel this complexity underlying mental illness. Thank you so much for joining us. Thank you.
Thank you so much.
Bye. Thanks.